Okay, so we're going to work on our problem solving skills today. We're going to solve problems involving a system of linear equations. Recall that a linear equation is of the form ax plus by equaling c, where x and y are variables, a, b, and c are constants. If you have a system of linear equations, you end up having two linear equations where, let's call this maybe a dx plus ey would equal an f. So you have two variables in both equations, and these variables actually represent the same value. Solving these problems involves a process where you need to follow these 5 steps. These 5 steps should help you with your thinking process through this. The first step here would be read and then reread the problem, obviously, help you gather your information. The second step is actually gathering your information. So you should gather your information and then write down and underline any given information that you have. Again, maybe reread the problem again so you can identify what's being asked. This should help you for step 3. Step 3 is actually identifying your variables. You got to identify and then choose variables to represent these unknown things that you're talking about. Step 4 would then be to translate this into equations for step 5 to solve the problem. Not only do you got to solve the problem, you got to solve for these variables and then interpret these results. So with these 5 steps, we're going to work on solving this problem here. This problem reads, admission for 4 adults and 2 children to Disneyland is $374, while 2 adults and 3 children is $285. What is the price of a child ticket? So after reading the problem, you may have to reread certain parts and then gather your information. So from me, I would say to gather what I need right now is I got 4 adults and 2 children is $374. So after I've got that part of my information, let's gather all of our information. So 2 adults and 3 children is $285. Now if I reread the problem, what is the price of a child ticket? So I have to identify what's my unknowns. Right now what's not known is the price of a child ticket and the price of an adult ticket. All they're asking for is what is the price of a child ticket. But we still need to make sure we label these things. So we're going to say X represents the price of an adult ticket. So let's say X is the price of an adult ticket. And Y is going to be the price of a child ticket. So same stuff, child ticket. So if this is, so let's see, so we've translated. We have not translated these words. So now we need to translate these words. So we've already read the problem, gathered our information, we've identified what's our unknown. So now we have variables that represent those, and now we need to translate this into some equations. So if we have 4 adults and 2 children, so let's say we have 4 adults plus 2 children. This has to equal $375. Well, if you have 4 adults and they all are charged a certain amount of money, and that's what we're talking about, X, they're all charged this price. So we're going to say 4 times X, which is the price of that adult ticket, and then 2 times Y, which is the price of a child ticket. This would be our first linear equation. Our second one would be the same look, just different numbers. So it'd be 2 adults times how much they cost, plus 3 children times how much they cost, and this is going to equal $285. So now we've translated these words into equations. Now we just have to solve this system. You can solve using any method you'd like. I think in this case it looks better for me to use an addition method. So I'm going to multiply this whole equation by -2 so I can get the same coefficient with the opposite sign on X. Multiplying this would give me a -4x minus 6y, and this would have to equal a negative. So let's go to the side and actually work this out, show our work. So this is times -2. Let's just say it's times 2, make the answer negative. So 10, carry the 1, 16, 17, carry the 1, 4, 5, so 570. So this has to equal 570. So now our equations is, here's our 1, here's our 2.
Negative 570?
It's a negative 570 at that. And that's because we're multiplying by -2. We should probably have this here so we can see what's going on. Now what we're going to do is we're going to add our equations using our addition method to eliminate a variable. If we add these two, we're going to get a 0. If we add these two, we're going to have a negative 4y. And if we add these two, okay, so 374 and negative 570, this ends up being a negative 196. And then we have to divide by this negative 4. Y equals 49. Okay, so we've solved for y. And in this case, we only need to know what y is because they only asked us what is the price of a child ticket. So if we were to interpret our results, we can say that price of a child ticket is $49. So we're going to work through another example using these linear equations. After reading this word problem, looks like a lot of these words are going to be underlined because we want to first read and then maybe reread the problem if it sounds confusing. So one number is 2 more than second. One number is 2 more than a second number. Twice the first number is 4 less than 3 times the second. Find the numbers. To me, that sounds pretty confusing, even if I read it again. So what I'm going to do now is I'm going to gather the information, maybe underline or write down whatever I need to write down. So here I'm going to say one number that I don't know is 2 more than the second. Okay, so one number is 2 more than the second. Now reading this, if I identify my variables right now, I definitely know my variables are the first number and the second number. So I'm going to say let x be the first number. So if x is the first number, y is the second. Okay, so let's keep on reading. So twice the first, okay, so twice the first is 4 less than 3 times the second. Okay, so using these things now, we've already identified our variables, so we have to translate this into equations now. So one number is, that's our first number, is 2 more. So if it's 2 more than something, we're going to add that 2 at the end. So it's 2 more than something, and that something ends up just being the second number. Okay, the next part, we have twice the first. So 2 times the first is, so 4 less. So it's 4 less than something. Something going on. It's 4 less than that. 4 less than 3 times the second. So 3 times the second number. Okay, now find the numbers. Okay, so now we have our system of equations. We need to go through whatever method we need to use to solve this. And to me, it looks a little easier substitution since x is already solved for. I'm going to plug in this part of this equation in for this x. So we're going to say 2 times x, but x equaling y plus 2 would equal 3y minus 4. So therefore, we're going to have a 2y plus 4 equaling 3y minus 4. I'm going to subtract the 2y over here, add the 4 over here. So this is going to say that y equals 8. So if y equals 8, that must mean x is 10. So if y is 8, x equals 10. If we were to translate our solved problem, we can say, well, our first number must be 10, our second number must be 8. If you want to go through and check these things, you can look at them now and say one number, the first number being 2 more than the second number, it's definitely 2 more than the second number. And then we can say twice the first number, so twice the first number, so it'd be 2 times 10, twice the first number, is 4 less than 3 times the second number. Well, 3 times the second number would be 24, and 4 less than that would be 20. So it looks like 20 equals 20. Therefore, this checks out.
All right, my friend.
Okay, so we're going to work out one more problem involving acid solutions where you need to mix something that's not so thick in concentration with something that's a little thicker to make something that you need in the middle when you don't have that. So we're going to start by saying Steve, he's a pharmacist, he needs 70 liters of 50% alcohol solution, and he only has a 30% solution and an 80% solution. So how much of each solution should he mix to make 70 liters of a 50% solution? Well, looks like somewhere in the middle. Looks like we can probably get 35 and 35. If we put 35 and 35, we might get a 50% solution. But since we're not sure, we got to think about this now. So if we were to gather this information, we definitely need 70 liters. And we need it to be a 50% solution when we're done. We have a 30% and an 80%. that we're going to mix. And now our question is, how much of each solution? So thinking of gathering our information, identifying our variables right now, we need to say that x and y are going to be our variables. We're going to let x represent, let's say, the number of liters of this 30% stuff. So this is the amount in liters of the 30% solution, and y would be the amount in liters of the 80% stuff. Okay, so now we've chose some variables to represent our unknowns. We need to translate this into an equation. So we definitely need 70 liters. If these are the amounts of liters, we need to add up maybe 35 and 35 or 40, 30. Whatever the case is, we know we have X amount of liters plus Y amount of liters is going to give us 70 liters here. Okay, so here we have an amount plus an amount equals the total amount that we're working with. Our other equation, we have to be mixing solutions with a solution to get a solution. So we're going to say we have a 30% acid solution of this amount. So when you're talking about of an amount, it's 30% of X plus 80% of however much we have of Y should give us a 50% of the 70 liters that we have. Now, turning these percents into numbers, we're going to say this would give us a 0.3x plus a 0.8y should equal a 0.5 times 70. Now, if you notice here, we have amount plus amount equals amount. Now we have a percent of amount plus a percent of amount equals a percent of the amount we need. It's very important that you get those kind of things matched up. Otherwise, it's like adding apples plus apples is going to equal oranges. You don't want to have things like that. You want to make sure your units are going to match up. Now for here, it looks like there's tricks you can do, and one trick is multiplying by 10 to every term or both sides of the equation to clear these decimals. So that's what I'm going to do here. We're going to multiply both sides by 10. And what this is going to do is give us a 3x, because 0.3 times 10 would give us a 3x, plus an 8y will equal a 5 times 70. Okay, this makes things a little easier. Now what we're going to do is we're going to look at these. So these are our two equations. We're going to look at these two equations and figure out how to solve them. To me, the best way looks like, in this case, a substitution method. So I'm going to solve for the variable, solve for one variable in the easier equation. So let's subtract an x from both sides. This tells us that y equals 70 minus x. Now we're going to substitute that into y in our equation. So we have 3x plus 8 times y, but y being 70 minus x would equal 5 times, so 350. Okay, and then solving for x, we need to do a distributive property here. So we have 3x plus 560 minus 8x equals 350. Now let's see if we were to combine some of this stuff. So what I'm going to do is I'm going to add the x's on this side to keep everything positive. So if we add, we're going to combine these x's. This gives us 560 minus 5x equals 350. I'm going to add this over here and subtract this to this side. So we're going to add 5x to both sides, and we're going to subtract 350 from both sides. So this is going to give us that 5x equals 210. Now dividing both sides by 5 gives us that x equals 42. So if we were to interpret these results now, because we've solved for our variable, so if we know x is 42, we plug in x 42 here, we're going to say that y is going to equal the remaining, which is an 8 and a 2, so we're going to say there's only 28. So interpreting these results, we must have mixed 42 liters of 30% solution and 28 liters of 80% solution in order to get 70 liters of that 50% solution.